Hi gang, and welcome back to Analyzing the Universe. One of the most remarkable and useful characteristics of our universe is that as we look out into space, we are also looking backwards in time. Since light travels about 186,000 miles in 1 second, when we look at the sun, whose distance is about 93 million miles, we are seeing it as it was about 8 minutes ago. Thus, our astronomical observations can yield a history of our universe by examining objects very far away. However, we had no idea of the vastness and hence antiquity of the universe until the 1920s, when Edwin Hubble discovered some innocuous appearing stars in a nebula or cloud called M31. These objects were Cepheid variable stars, which we have encountered before, and which have the unique feature that they pulsate, actually growing and shrinking over a period of several days. Moreover, the amount of time it takes for these stars to pulsate is directly related to their intrinsic luminosity, how bright they really are. Once we know an object's true brightness, it is a simple matter to use its apparent brightness to calculate its distance from us. It was undoubtedly with a trembling hand that Hubble calculated the distance to M31, our nearest spiral galaxy neighbor. It was over 1 million light years away. Just imagine light that can travel over 7 times around the world in 1 second takes over 1 million years to reach us from M31. Thus, when you go out on a clear autumn night and find M31 in the constellation of Andromeda, you are seeing that object as it actually was when the first human-like creatures began to walk the earth. With the knowledge of the distance to far-flung astronomical bodies, a wonderful side benefit emerged. We were able to find the dimensions of an object from its angular size in the sky. We did this recently when we discussed Cas A, but here we'll calculate the size of M31. Modern, more accurate measurements place it about 2 million light years away, and its apparent size in the sky is 3 degrees, about the same apparent diameter as 6 full moons placed side by side. What is the size of the Andromeda galaxy? So we have a big, skinny triangle. The angle of opening is 3 degrees, which is equal to about 1/20th of a radian. We have to get everything in units or non-units of radians so that we can make the comparison of the size in the sky and distances together. And we know we have 6 full moons spanning M31. And if the distance to M31 is 2 million light years, then this distance here, the size of Andromeda actually is going to be 2 million light years divided by 20, or approximately 100,000 light years across. With this awesome revelation about the size of the universe and some of its constituents, an avalanche of observations opened our eyes to yet more astounding facts. With the study of other galaxies, an exceedingly interesting relationship emerged. The further a galaxy was away from us, measured by the Cepheid variables and other techniques, the faster it appeared to be moving, as measured from the Doppler shift of its spectral features. It was as if the entire universe was somehow exploding into space. The faster each piece was moving, the further it would be away from anywhere else after a given amount of time. Because of this unique relationship between velocity and distance, known as the Hubble law in honor of its discoverer, we now had a new method for measuring distances to really remote objects. All we need to do is measure the Doppler redshift from the energy spectrum and deduce the distance from a very simple equation: velocity equals a constant, h, the Hubble constant, times the distance it is away. Here, h is the Hubble constant and has been experimentally determined to be about 70 kilometers per second per megaparsec. Thus, for each million parsecs in distance away from us, which is about 3 million light years, the object's velocity increases by 70 kilometers per second. So, for example, an object whose spectrum exhibits a velocity of 500 kilometers per second would be at a distance of about 7 megaparsecs from us. The stage was now set for the discovery of the quasars.